So first of all, good morning, everyone, and welcome to CppIndia community. I'm Dheeraj Jha, a software engineer based in Bangalore, and thank you for joining this session. So let me give you a brief about this community. So CPP India aims to bring together the Indian C++ community to facilitate sharing, learning, and expansion of their C++ knowledge. This is a platform to discuss, share, showcase your C++ work, and seek and provide guidance for C++ related topics. So if you did not join registered in CPP India uh, page, go to cppindia.co.in and fill the registration form. I will request everyone to join our Discord channel. There we interact and you will get all the notifications about this community, and follow us on LinkedIn, Twitter, and Facebook. And if you have any query, please contact us. We organize sessions every alternate Saturday on topics as per community feedback and directions. You will receive a feedback form at the end of this session. Please spare some time, couple of minutes to provide appreciation, constructive criticism for today's session. It will help us to improve in next session. So without further ado, let's start with the presentation. Today we have Ankur Satle. He has 18 plus years of experience in different phases of software development in various domains. Today's session is in continuation of our last session, in which Ankur covered the basics of templates in C++. If you missed that session, you can check out our YouTube channel and watch that. So now I will request Ankur to take control of this session. So Ankur, all yours now.
Thank you, Dheeraj. I'll start with a thing. Perfect. So welcome again to a deep dive. An introductory dive into templates. We took a look at some of the aspects around templates in the last session, which was part one. And when I asked the attendees of that session about what they think about templates, this is what you all said. It was that they are generic functions, they are generic programming, compile time and compiler adds code, type as param, overloading, footprint, generic class, readability, tough to make generic, strenuous effort, hard to debug, complex and difficult errors. So there is a lot to templates. A lot of C++ is about templates. We covered those aspects more or less in the previous discussion, and we'll continue thereafter to cover the rest. We covered that functions is to reuse, what function templates is to super reuse. You can use them not only for the set types, but for different types. They're totally generic. Compiler instantiates the functions with parameterized types, and we saw real life example of the process function, which dealt with many events. How instantiation works, starting in a translation unit to how it keeps one copy in the binary, explicit type specification and automatic type deduction, how compiler deduces, you should specify only when you must. Okay, generic functions with auto parameters, function templates with multiple parameterized types, and there was one topic which which was a short one, which I would like to just cover from last time. And I wanted to remind to all of you from last time that if you know any programming, you already know generic programming with templates. Says who? I do, and we saw a bit of that last time. We'll continue. Who am I? I am a modern C++ enthusiast, uh, evangelist. I'm an architect. There's a lot written there. This is the same slide from last time. My friends claim that I don't write code without using templates. Uh, well, not completely true, but not completely false also. So easing into templates. Let's put templates with the right understanding in the right place in our heads, in our understanding, and replace the doubts, concerns, apprehensions. We will look at what we know and use it to learn templates. Okay, templates save us from donkey work, from implementing all possible type combinations, etc. So we saw this example, this very example last time, where I'll just start my pointer. Okay, so we saw the copy function, which took input iterator in and end, and an output iterator, and it would copy everything from in to end into out. Okay, and making the input type and output iterator types generic helps you deal with any kinds of inputs. And we were very happy to see that this one template would instantiate different instances when used with lists, vectors, and any other data structures. We touched upon these two last time. But if you imagine there are three kinds of data structures which you would like to have copy with, and you could copy from any of these to any other, you get into a combination problem of 3p2, which will be 6 possible instances of the functions would be needed in order to cover all scenarios, which means vector can copy into set, set can copy into list, list can copy into vector, and each one into the other. If instead you have 4 data structures, the problem of combination just keeps on increasing. It goes to 12, and this is exactly what you don't want to do by hand. Okay, writing all these by hand is copy paste and not what a man is born to do, right? It's error prone, it's tedious, wastage of human effort. And I hear sometimes people say we only create those that we want. Why have everything? But I would instead say, why re-implement anything anyway? If it is absolutely looking just the same, why lose time on doing something manually, which the compiler would do? So just stressing on the point that code is generated by the compiler, it is correct by default. Human effort is saved, which is what all is about. All of this is about. Generated binary has only those instances which are really used. You don't generate all the 12 instances that may be possible. You only generate and keep only those 2, 3, maybe 1 which you use. Inlining eliminates function calls. It's a win-win situation. And this is a point about footprint also. You only have what you will use, so there is no extra bloat of code, and not in the binary. Okay, so life is better with generic programming and templates. Now let's look at how our understanding of polymorphism and see how we can work with templates. Let's quickly look at how C deals with polymorphism. If you look at standard lib, it has a quick sort function which is supposed to sort any type. And what do they do? It takes a void pointer where the data type is not really known. It is obscured into this void pointer, and then there is a count and size. There is a comparison function. Okay, I think I have the points noted. So for sorting any user-defined type, you have to convert your data type into a void pointer. Essentially, the benefit of these languages, C and C++, is that they are that they are type aware, that they are strong on types. And if you convert it into a void pointer, you are essentially losing all the knowledge of the type. And no wonder the programmer then has to provide the size of each item, which the compiler already knows. If you use a struct with 3 ints, it already knows that it is size of 3 times an int. But here, because we are losing all knowledge of the type, we have to pass the size of our type. We have to tell to the compiler what it has already generated there as the size of the type. So this is a bit reverse in my understanding. And qsort deals with items in terms of memory bytes. It is not well aware of the data types. So if you want to sort your items based on let's say uh, only some of the fields, that's when you provide the comp function, which actually does something smart. And you know what? In the comp, you will still get the void pointers. You have to assume that they are the right pointers. You have to typecast it into your type, which you should know in that comparison function, and then intelligently work on it. Okay, that's how the comp has gotten there. So you have to redo all, because compiler can already compare objects by itself, but you still have to provide a comp function. You will have to write one, and context is just an argument in case you need it for the comp. I'll not go into that. So this basically is just the reverse of how it should actually be. The compiler is aware of the data type, but we lose all its knowledge. Not a good strategy. C++. So let's look at a real life example. Let's say we have a class called as a message, which has an add string kind of a method, which is virtual. Okay, and as you see, it is pure virtual. It is not implemented in this base. From this, you have a request and a response class. Each of these implement the add string overriding from the base. Okay, and it gives you a string. And here you can write an operator. Suppose you want to write it out into a JSON or something. So you implement this operator for the O stream by accepting the base class, and you invoke the virtual function, so the right behavior polymorphically kicks in. Okay, this enables code like this. You would use it by instantiating a request and pointing to it using a message pointer, and then you will redirect it into the O stream, so it writes out whatever it wants to write. Okay, here we have dynamic polymorphism, which means there is a virtual dispatch. As string method is called, we know on an object, but we don't know which object it is going to be. So there is no knowledge of that through the virtual table mechanisms. You will get this call, but it will be an indirect one through a function call. Okay, but that's the benefit, that you are writing one code and it works for any kind of object. You could also have a response here, and you would have to write the same code in order to stream it into JSON. Okay, that is good, but there is always a dynamic dispatch. Okay, indirect function calls and function call jump also means that you have an instruction cache miss. The next instruction is somewhere else in where the function body is placed. It's not right there. It's not. You have to jump and make a function call. So there are overheads here. Okay. So this is a dynamic polymorphism case. Now, if we see templates, how they can help, we would have the same request and response classes, but they wouldn't be inheriting from some base class. They can be independent data types, and they still have the as string function, which gives the string, which is what the operator depends upon. This code is still looking just the same, except for receiving the base type. You would just receive a template, which would be that specific type. And how do you use it? Now you can use the actual data type, which is the request, and then use it into the JSON string. And here the compiler will instantiate this operator and invoke it at this place, and then you can see that the real data type, the T here, would be deduced to be request, and that instance will be called. There is no virtual dispatch. In fact, it works on unrelated data types. There is no virtual dispatch, and in fact, there can be inlining, which can just put this body where the invocation actually happened, and there is no function call there is that much more performance benefit. This is what templates bring to you. We use C++ for performance reasons, and this is exactly why we do it. Okay, so now let's look at a comparison of how the dynamic polymorphism versus static template based polymorphism can work. You can see both the objects are same. I have just abstracted out the data type to a base. Obviously it's a base and there will be a derived class. Okay, so let's see the usage. When you have a new derived, when you call this even with the derived object, in case of polymorphic objects, you would end up calling the base instance. Okay, because derived is a base and there is no operator that you define for the derived type, you derived it for the base. And here the way you convert something into a string in standard C++ is to use a two-string function in order to convert the object or whatever data type you have into a string. Okay, and so I've just gone to the more standard style in this presentation, in this slide. So you have the toString which is called on that object, and now if you see, if you did the standard stuff, if you pass the base object to toString, the toString function knows that it is the base object, and this is called as splicing. It is not aware that it is actually the data type of derived. It is not aware of the extra data members, but the toString would actually stringify the base part of this object and not the entire derived object. This by itself has started to go wrong. Okay, if you imagine a game, okay, where you have so I'm just taking a concrete example where you have a character called as monster, and you point to it via this object of player. If you send it, and if the operator is only implementing the base, is only accepting the base type, this player would lose all the monsterness and would just work on the base layer. Okay, you would just get the output of the toString for base only and none of the monster parts. That's a loss. It's I mean, it's incorrect. It's not probably what you thought you were doing. Okay, so references to base result in splicing. Templates use the correct type. Instead, if you use the bottom example, the correct data type will always be inferred. In both cases, this will be derived and this will be the monster, and the right operations will happen inside there. Okay, implementing for base did not help similar usage for player, right? Okay, so even though you had the base implementation, it cannot help player. Okay, so what I wanted to point out was splicing happened here, but here the data type is different. You implemented something very generically, but it did not work because monster derived not from base but from a player object. So monster had a different base class, but this implementation, although it is looking just very similar, it is not going to kick in. This will be a compilation problem. Okay, so more comparison. This is the same two functions on the left hand side. When you see the usage, if you have a number, and if you call the number, if you call the stream operator on the number, again, your base implementation is not going to help for basic data types. Int can never be forced to derive from the base. This is why, even though you have something for a base class, but it is only limited to the hierarchy of that base class. Instead, if you have the template, it works for any data types, no problem. Okay, just to hammer the concept through, we have message. Again, coming to the polymorphic example, we have the message and we have the request and response deriving from it. And if you have the message type implemented, you cannot use it for any standard library types. Yes, you can imagine that, let's say for int, you cannot derive it from the base, but there can be other objects which you very frequently use. So this is a name to value mapping. It's a pair. This goes very well in a JSON, but you won't be able to benefit from this implementation because there is no matching function which takes a pair, and pair doesn't derive from base. Okay, so you have not only the primitive data types, but the third party standard library or external library data types, which you cannot do anything like asking them to inherit from your base. And inheritance, that's why, is intrusive, and it's not going to solve this generic problem. But if we know polymorphic code, if you just make a template out of it, it works. It works for all data types. So if you know any OOP, you already know generic programming with templates. I say so. I hope you can see the point. Okay, not everything is all rosy. This is the inheritance-based mechanism. I'm not introducing new things here. This is a very similar code. Message inherits, message is a base class, request inherits from message, provides as string. The operator is doing the as string again. Using code looks like this. You have the base class MSG object and you see out using the MSG. Now this, because there is a virtual dispatch here, it will take care of the right thing, but this results in a compilation error. And can you spot it?
It's not defined.
What is not defined?
As string is overridden, but it's the base class. Where is message request? The base class is pure.
Yeah. Okay. Okay. It's not because the base class is pure. The base class is pure, but the child is actually having a different signature here. Sorry, I just slipped that in just to make the point. So here, if you use the keyword override, this code will not compile because you think you are overriding a base function, but the signature of the base function is taking no arguments, but you are actually taking an int here. And this is why it would not compile. So the compiler is able to help you in terms of inheritance, that your signature is missing out, is not matching with the base signature, and you will be helped by the compiler at that point. So the compilation error is here in the as string method. Okay. So that's the problem. I just pointed it out. So in case of polymorphic types, thanks to override, you are able to catch these kind of errors. But if you had templates, okay, your request will not inherit from anything. You still have the as string with int, but in the template, you're trying to call it without any arguments. And that's where now you will get an error if you try to use just the same way. And the error now is pointed out on this line of the template, which is very unfortunate. Maybe sometimes you don't even see the body of the template, or it's embedded somewhere in the library, in the standard library or a third-party library, or even your own libraries. And at the point of use, you don't see what's going wrong. Here you will be getting an error message that inside this operator, which is called from this line, where T is the request, where T is data type, which is the request, you don't have any function which matches as string. Okay, and you will get some suggestions. Did you mean as string with int? And that's the kind of errors that you get with templates. You get at the incorrect use, you get these errors at the incorrect use at this point, unfortunately, and not when you try to use or not telling you what is going wrong. C++ concepts try to help you here, but if you don't have C++ 20, you are left alone dealing with errors, and we had some feedback from you guys also dealing with errors. So this is one reason why you would have errors, and unfortunately, override doesn't come to your rescue. You cannot use override here because you're not using inheritance. Okay, so this is one help which compiler could provide but is not able to provide. Although this code will not compile and do the wrong thing, it will stop your compilation right here, which is what the good thing about templates is. It won't let your code go through till it is right and it is fully formed, correctly formed. And so this line you'll get the error. Okay, we get into the realm of template errors, which some of us dread. It's just that the template errors are long. Sometimes the compilers try to tell you which line you started using this template, which is that line which I'm pointing to, where it went to from that, then it went to from that, and then at that location it tried to call a template where you got into error. So once you enter into template, the compiler tries to help you with a lot of information through the call stack as to how your code progressed and reached that line which has an error, which could be 3 levels deep or something. And this is what people dread about the template errors. Okay, so briefly, I would just say you have to look at the first line where it shows the usage and see that it is determining the right types for the template, and then you can look at the last line which actually points out the error, and there could be some intermediate mechanisms in the middle, some intermediate calls, which will be helpful if you want to debug at all levels or for specific cases. But usually the best way to get what is wrong with the template is to look at the usage line where it all started and to look at the line where it is pointing the error, and there will be a lot of call stack which can help you debug some other situations.
So Ankur, a simple point to interrupt. Sorry for that. So as you touch the debugging part, like we know templates are really great, but the debugging really is a pain. So are there some great tools to help you debug those templates? Just a point to ask, because that's a pain when it comes to debug the templates really.
Yes, so when you talk about template errors, the compiler is your best friend. It gives you all the errors, although the errors may be a little problematic. If you use a good IDE, then the IDE can help you right there. So even if you go to godball.org and if you type in your code, as you type, your errors would be pointed out there as to where things are going wrong or something is not well formed, etc. So these are the two things which I can right away tell you about. I don't think any static analysis tools add anything more than showing you the right errors. But getting a good grip, so getting a lot of these errors and just understanding how to look at them is something that a bit of experience and a bit of diving into this will help you form. So I know errors were raised as a concern by people in the previous session, and I would like to cover them, although I did not have a lot of time to gather all kinds of errors and kinds of places where templates would go wrong. But usually the errors are that you think you are calling template X, but you ended up calling template Y. Okay, because there is an overload and what you thought would be called is not being called. So there's a bit of a surprise there, but mostly these errors are compile time. With templates, sometimes, most of the times, you can say if it compiles, it works fine.
Yeah, thank you.
Thanks. All right. So let's get into class templates. We have looked at templates with functions, okay? And I'll be quick on this one because it's a similar thing. You have vector of ints, which could be a class which manages a lot of ints as data and knows the size of how many they have, how many it has. Similarly, you'll have to have vector of strings. You use vector of ints by instantiating with ints. You can instantiate the vector of strings with many strings, and this is how you use them both. Very similar cases, and but it looks like donkey work. You have to instantiate a new class, create a new class, vector of strings, vector of mighty, vector of employees, vector of events, vector of anything else, floats. So you would get into that uh, a lot of manual creation of new data types. So instead, of course, the answer would be templates. So you just introduce templates and manage a lot of T's now inside a vector. Okay, this is what the standard library provides, and we have, I guess we all have a fair understanding of this. They both look just the same, and this is still a vector of int, and this is still a vector of strings. And not only that, you can now also have vector of events, which is your custom data type, and you can just use it normally like you would use any of these other data types. Okay, events.pushback, events.size, events.back. You are able to use all of that. So template is smart work. Go for it. Okay, where do the templates help us? Templates would help us creating algorithms, sort, copy, binary search, reduce. We have these in the standard library. Many of these are, most of my examples, I guess all the examples here are standard libraries. Utility functions like swap, exchange, I'm just naming a few. You have function objects of the apps which abstract the function itself, invoke. You have plus, which does a plus of any two data types. You have not equal, which does a not comparison equal of two data types. You have bind, where you freeze some parameters of a function that you want to call. Okay, you have utility classes like pair, tuple, tuple, hash. You have containers. We know the most, I guess. Vectors, array, list, set, multi-map, ordered map, unordered map. I'm sorry. We have datetime, which are also templates. We have time point, which is a point in time. Duration, zoned time, which has knowledge of its time zone, and there are many other, these data types in the chrono library standard. So, but these are only standard constructs, right? Are the templates only restricted to them? Can we not go beyond these? And this is the point that we start looking at a realistic example. We all use WhatsApp or any such application which is pretty close to WhatsApp. It's a messaging, a chat application. So let's consider a chat application like WhatsApp, which enables sending and receiving messages over some connection and using a protocol. Okay, as you can see, this is a very scaled down version of the problem statement of what WhatsApp does. But you use some protocol to communicate over some connection that you use. And why do you do that? You want to send and receive messages. That's what this application, the chat application, is for. So let's consider the sender class. So if you see, you might design a class sender, which has a send method, okay, a send function which takes the remote and a message. So who you want to send the message to and what is the message, and you get back a new chat ID. So when you chat with a person, you have a session, you have a chat conversation going on. So you get the chat ID and the message ID, which you just sent. So you get two things back. Okay, once you are in a chat, you send more messages on the same chat ID using the chat ID from the previous one, and you send new messages and you get new message IDs. Okay, and it uses some socket in order to do network communication over to the server. Okay, how do you use it? You have a sender which you initialize with server details. So let's say we are talking of a sender at a client which is there on our mobile. So at a client application, so you instantiate, you have a sender, and you send a next message to some number, and you say hi, and you get back the chat ID and the message ID. Okay, this is just usage. Okay, all fine. So realistic scenario. Now, if you analyze what we have built here, which would be a very typical design that somebody would make, the sender seems to be doing too much. Okay, according to me, it receives the end user message. It receives the end user message string in the send function. It gets the MSG. It has a network descriptor, socket descriptor, and we can say that the send function encodes the message into a network message, some protocol kind of a message. It had to encode the message which you sent into a protocol kind of a message. It sends it over the network connection, so it is responsible for socket operations, etc. It gets back a response with the chat ID and message ID. This by itself is too much functionality. It's too much in one place. And if you split the concerns, you can have a much better design. Let's look at some ideas here. So let's say you have, let's say the protocol is CIP protocol. You could use any protocol, it doesn't matter. Excuse me. So this is an encoder which takes a remote and a message. So and it encodes the message into an encoded message which is specific to the protocol. Okay, you would have who you are sending to in some header part, and then there's a body which is the message, and that's the string which you send. Okay, so you can have something called as an encoder. And how do you use it? You have an encoder and you say encoder.encode to this number, this is my message. And you get back an encoded message which is good to go on the network, right? How about the network connection? You can have something called as a TCP connection, okay, or a UDP connection, some connection type, which would actually have the socket FD, and you would have a write function there, which would take any span of adjacent bytes, some bytes. This object doesn't care what it is. It could be a very well-formed message as per some protocol, but for this socket kind of an abstraction, the socket connection abstraction, it is just bytes. So you just receive bytes as message, and you do some socket operations, and you write the message to the other party. Okay. And how do you use it? You have a TCP connection, you get the encoded message from somewhere, and you say connection.write, and that writes the network message. Okay. Now, if you use these and create a sender, you could have something much better. So the sender class is definitely needed. Its API to send is definitely needed. Send within a chat or send to a remote to start a new chat. But we introduced two template types, which is the encoder and a connection, and have an instance of each of those. So you have an encoder and have a connection, and this sender uses both these to achieve its functionality. And the encoder does its job, the connection does its job. So what would the member functions now look like if you have the send function implemented? Your send function would look like something like this. This is the base signature, just maintained from the previous slide. Okay. So you have the sender class with some encoder and connection. Okay. But do you know what it is? No, right? The compiler does not know what encoder and connection is. So you have to tell it what it is. So when you create the body, the member function out of the class, you can do that even for templates like we are used to for regular classes. You have the body which just declares the functions, and you have the you have the class which just declares the functions, and you have the definitions somewhere else, let's say in a CPP. So even though you have to put this all in the header, you still can put the body out of the class. And this is how you say that you are talking of a sender class, which takes two template parameters, encoder and connection. And with that data type, you are implementing the send function, which takes remote and message. Okay. In that, what will you write? We saw the usages of both these. Encoder.encode will encode the message and give you a network message. Now this is good to go on the network. Now you do a connection.write with that network message. And there is more code to get back the chat ID and message ID, which some other specific data type should do. And then you return the chat ID and message ID back. Okay, so this is what the implementation looks like. It is itself not doing a lot of work. It is just gluing functionality of encoder, connection, and let's say a response mechanism together to achieve the higher level functionality of sending messaging. Okay, so member functions of a template can be defined out of the class body, but you have to make sure it is there in the header, and you have to also maintain the template parameters and declare them before you start to use them in the class. Okay, and now let's see how to use the beta sender. You have a sender which is taking a SIP encoder and a TCP connection with the same server details. Okay, now you get some user input. Let's say user is typing in some text box and you get the message and to whom he is chatting, all that information you get. And now you say sender.send with remote end message. You get back the chat ID and the message ID. Okay, you want to send another message, you go back to get user input, you get another message. This time it is in the same chat. So you use the second function, which is just doing the send with the chat ID known, and you send the another message and you get the another message ID. Okay, so using code is almost the same as before. So when you had the original sender, you used to call sender.send with remote and message, just still doing the same. Okay, but right now your code is more ready for the future. You have we have seen this with WhatsApp. Now our messages are end-to-end encrypted, right? So there is some security. Anybody listening to the messages on the network will not be able to understand, will not be able to decipher or read your messages, right? This is a very good and much needed functionality. That's not how WhatsApp started. Change is the norm, and we have to be ready for it, and our implementations have to be ready for it. And how do our templates help us? Now, instead of using just a bare TCP connection, which would just send clear messages to and fro, if you instead have a TLS connection, which is a secured way of connecting, it sends encrypted messages through. Now, if you see what the usage looks like, this code is very, very repetitive. Guess what? Nothing changes. All of the same infrastructure, all of the same sender code, all of the SIP encoder, the same user code is able to deal with now a secured connection just because you abstracted out and parameterized the connection. And now you have a secured connection, your messages are secured, okay? By just introducing TLS connection. Okay, it's a big step towards code stability. Now, much of your code does not change. You're not changing the sender because now you want security. You're just not using the TCP connection class, which is still good enough for any other usage. Okay, you still have that class. It is not modified. Now you have a new class which you implement TLS connection, and just you start using that with the same kind of interface, which gives you the right function, just like TCP connection did. And this now is able to deal with the change in life. Okay. Templates are a customization point. So this template, having this template actually helps you customize the behavior of your application. Okay, last time we took just a random example of the strategy that the game uses in order to play against you. If there is a code written which is the game and you're playing the game, let's say it's a chess game. If you choose an easy level, the game will think only 3 moves ahead and will use an easy strategy object, let's say, against you. And if you use a hard one, it will think 20 moves ahead and play with you, play chess with you. So it would just be replaced by a different kind of a strategy, different kind of logic, which is all encapsulated in one strategy object, and you can now flip and change the object and enjoy a different behavior with the same data type. And as you see, everything is segregated into its own focused part. Okay, so with template parameters and types, they become quite a lineful. I just wanted to help you with the readability part. They could grow bigger. Say sender is taking 2 data types. So every time if you refer to this data type, it will become quite a lineful. and quite a mouthful to say and talk about it. So of course you can come up with your own names and just have a different name using secured sender, which is nothing but a sender SIP encoder with TLS, a sender with SIP encoder and TLS connection. Okay, so and you're calling it a secured sender. This is just the equivalent of what type defs were in C. So you just have a using declaration here. And how would you use it? So instead of your code doing this, naming the type at length, you could now use a secured sender, and this looks very peaceful. Okay, you can have other such examples. Shared resource. Say you have a resource, but you have a shared resource. And how would you have it? Let's say your resource is just a vector of events, and you want to guard it with some mutex and have some sharing. You might have a resource class which has a vector of events and a mutex. Instead of saying that long string, you can just use a shared resource and use it accordingly. So just help yourself with using declarations and don't get lost in the jungle of angle brackets. Okay, we have the mechanisms to help ourselves. Okay, life is better with generic programming and templates. Okay, templates also help with testability. Okay, let's look at how you manage dependency of data types. Templates help with testability. As you can imagine, you can pass any encoder and any connection. How about passing a mock encoder and mock connection? This is exactly what you want in order to write test code. So now your sender class is very, very testable. And you can now say sender.send the same strings. And you also, and in the test, you say this is catch2 syntax, please. You can use any UT framework, which is just doing an assert here that the return from sender.send is matching with a chat ID of 1 and a message ID of 100, just some random expected things. But I'm just showing the point to you that you get back the functionality, and the same implementation is very, very testable. You don't have to do a lot of jugglery in order to prove that your code works and your automated tests are ready. If you now use this section number 1, chat ID 1, you can now send another message of bye, and you get another message ID back, and this is what defines the behavior of your class. This is very, very testable, right? By using mock encoder, mock connection, we can test the sender controlling behavior from the mock classes. So you can have the mock cause some errors sometimes. You can have a throwing mock. You can have a negative returning mock. You can have a disconnected connection. So you can have introduce these things in the code. You can have a delayed response. So when you call it, you don't get a response for, let's say, 20 seconds. We have to see how sender behaves. So you can do all of that by just mocking these classes, creating your own little classes which do the kind of behavior or misbehavior that you want to cause in order to test the entire logic of sender. Okay, this is super duper. And moreover, SIP encoder and TCP connection are also independently tested. You did not need the sender to be able to test SIP encoder. You just have a message and the remote, and you are able to separately test encoder. You can separately test TCP connection. Okay, test coverage goes up very high, and the code is not a big ball of mud. It is not all jumbled up. Okay, every individual part is independent and simple to understand. Every concept is small and simple to understand. Please don't mind if you have lots of header files, lots of small classes. That's the right way to do it. Okay, and combine them using templates. You can have all sorts of combinations. Like we said, can you have an HTTP encoder with the TCP connection? Of course, yes. Just implement the HTTP encoder and use it with the sender. Can you now move to a UDP-based secured connection, let's say using quick protocol? Hell yes. Just have the quick connection. Just one new connection object which conforms to the expectations of a connection, and there you go. Okay, that is reuse plus plus for every individual concept. Each of these is an individual concept and totally independent from the others, and that's what templates give you. This is a real. I just wanted to present a realistic example of how templates can be used in production code. Life is better with generic programming and templates. Okay, member function templates. So we saw functions can be templated, and so we'll use our extra. So whatever knowledge we had about functions, we use them. We use that to create member functions. Similarly, whatever knowledge we have gathered for writing function templates, we can use that to have member function templates. Okay, so here we have a very basic class of email ID with an operator equal to, which matches with a string. Okay, how do you use it? You have an email ID. You get, let's say there's a lucky draw, or there's a good performer, and you get the winner in the team. You get his user ID. You match the user ID. If it is this one, then you award this employee. Okay, you got employee's email ID, and then you're able to match it with this string. Okay, because this operator is implemented by this data type email ID. Okay, but matching is only with std string. Is that good enough? How about const char pointer support or string view support? If you have not viewed the string view session which Mahendra took previously, please check out YouTube for us for the session on string view. Okay, it's very informative. So if you could have other data types, so what do? The moment you want to support more data types, you come into the realm of templates. And this time it's a member function template. As you can see, the class is itself not templated, but you just have a templated function where you say, I just take anything which is like a string, okay, and I'm able to match it. Okay, so again, the usage is pretty much similar. You take the email ID from the employee, and you get the const char pointer this time from some query ID. Okay, say somebody queried for an employee, and you are doing a search. So you can match it here and display the employee, right? So this is a different use case of this member function template, of using the same operator, which member function templates enables us to use with a different data type. Okay, so just your knowledge of the function template now can be applied to member functions. The class itself may or may not be templated. Okay, there is no restriction on whether the class is also templated or not. You can have a template function inside a template class. Welcome to the world of templates. But you will take the choice where it is necessary. So if this class also needed to take some template argument, you would just have the class being templated with some type T, and this operator being templated with some string-like object. Okay, so the class templates and member function templates are both available within the body of the member function. So in the function where you write the operator equals, you will have the class, the type T of the class itself also available as a valid type, and the string-like is also a valid type inside this function. Out of this function, if there are any other functions, string-like is obviously not known to be something. You would get some compilation errors at any other part of this email ID object, except for this function where you said that it is a type expected from this inside this function. Okay, so do more with less. Life is better with generic programming and templates. Okay, at this point, I would like to conclude part 2. Templates are great, and they are indeed the answer to so many questions. If you are looking for something where the types are changing, but more or less the code is the same, you must think templates. All right. So what we walked through in this discussion was templates, You create instantiation for every possible type and combination. An instance is created only for the types that you use. You produce optimized code as against polymorphic code, which has an indirect call, or typecast based code. You have templates which deal with the strong types. Okay, and even you're able to inline some functions where possible. Enable building utilities, containers, type traits. Okay, so the standard library has a lot of these because they are really very helpful and they can tell you things, they can help you do a lot of things. Much of the mundane work can be achieved by using the standard library, utilities, etc. And any that you write. So if you think you have a new algorithm which you need in your application, do not embed it in in 200 lines of a function somewhere there is an algorithm hidden. No, pull it out, please. Create a template function and just call your data type. You will thank yourself when you need it a second time. Okay, that's the right way to build maintainable software. You can also prove that small function to be testable independently of this entire big block of code. Okay, just some good practices. Help with higher level code and in keeping functional separation between concerns. So we were able to separate the encoder and still use them together, encoder and connection, and still use them together to have a set. Okay, it assists with testability. Everything is small and specific to the data type. And just pass a mock type and you're able to test it well. Okay. And okay, just to remind you before we end, and this is what happens when you add a slide at the end. But this is the reminder I wanted to give you. Life is better with generic programming and templates. Okay, so there is more to templates. There's something called as dependent types. When you have a templated argument, you can use its dependent types, some types that it declares. You have non-type template arguments. You can pass, let's say, an int to a template. You have function specializations, class specialization. We have explicit template instantiation. Okay. We have templates errors. There can be a lot of different kinds of errors. It is very difficult to hunt and bring all of those. But if we plan a next discussion, which is something that I guess the feedback form is also going to ask you guys about. So these are the points that I would like you to go back and look them up and read, learn, and if your feedback is so that you would like to discuss any of these, I'm there for one-on-one, or we can have a follow-up session covering these variadic templates, forwarding, policy-based design. There's a lot. Okay, so with the reminder, do generic programming and use templates. It improves life quite a bit. I invite any questions that you may have.
Thank you. First of all, thank you very much for taking the time to present on this, interesting subject.
Thank you.
My question is, if you were to do a next talk, like maybe in 2 weeks' time or whenever, could you go into concepts and specifically, how concepts tie with templates? Because
yeah,
right, because I'm asking because when I saw your example string, like I immediately thought of like using concepts or something of that sort.
Yes, very good. Yes, in fact, even the polymorphic case, which was solved by the templates, you would the override kind of a problem, the thing that override did not catch, that is also something that the concepts will catch. Okay, that you had a signature mismatch and the concept says, I expect such a function to be there with this type, but I don't have. So at the point of instantiation, it would give you the issue and not 10 levels deep inside the template. Yes. So these are very helpful things. There's a lot to play around before we reach there. And I would guess, I would take feedback, guys. Please take this opportunity to fill in the text in the feedback form. Guys, I guess you would have posted the link. in the chat.
Yes,
So,
it's there.
so if these are the points where I had sorry, I'm not focused there. So if these are the points that you would like to discuss, or it is C++20 concept, we can go through those in due course. More I cannot promise for next time, but I don't mind taking a session next time. You guys would be bored of me. I'm not bored at all. This is lovely stuff. So if you can provide your suggestions on that. But C++20 concept, yes, let's put it on the anvil.
Ankur, there was one question in chat window. Abhay asked this question: can we have virtual template functions? Something like that.
Can we have virtual template functions? You mean the class is a template, and the functions inside the class can be virtual?
Abhay,
No, yeah,
are you there?
yes. I mean that like a class is a normal, and
Yes.
inside that, just like we can define virtual function. Just like can we just my intention is to ask to can we have a abstract template class?
Abstract template class, I guess so. I've not tried it myself, but yeah. Anything that you can, so anything that a class can look like, a class template can also do the same. So feel free to introduce virtual functions inside your template types. Okay. You can even accept template parameters which become your base. So you can have a template T which is coming in your class, but that is your public base of your type itself. You can have that kind of a code. I've done that, and you can definitely have virtual functions inside. There is one catch though. If you use templates as a base, the functions of the base are not inherently reachable from the derived. You have to mention that you are going to use f1 function of the base. So if you have let's say a template is passed a base, let's call the template as base,
Okay.
and you create a new template which is deriving from base. The functions of this base will be available in the derived type only if you have a using declaration for the base type. So you have to say using base : print. So the
Okay.
print function from the base will now be available in the derived.
Can you
This
give me any real-time example for this? That
uh,
means you came across in your.
yeah, a very real-time example is a little reverse of this. Something that quickly comes to my mind here. A quick real-time example would be CRTP, curiously recurring template pattern, where you declare a class, and the class is actually a base class, and it expects the template of the derived. It expects a template, and in the template you have to pass the derived data type. Okay, so it sounds recurring that the base needs the derived as the template, and the derived itself would need the base to inherit from. But all this is well-formed code. The C++ template logic is Turing complete, you may know, and so this is a valid syntax for having for bypassing not having virtual functions and virtual dispatch. So curiously recurring template pattern, you can look this up, is used for eliminating virtual calls.
Okay. CRTP you said, right?
CRTP, curiously recurring template pattern.
Okay. Okay. Thank you.
Any further questions? Anyone?
So yeah, hi, Ankur. Thanks for the talk. So one question was, so you mentioned that we can do various combinations of some template class or template functions. So let's say a template, it can be situation for a class, it can be a templatized class, or it may not be a templatized class. and the member functions may be templatized or it may not be. So if you think of 2 times 2, it would be like 4 combinations. Going further, you can inherit, let's say, for a simple class, you can inherit from so like there could be, based on inheritance, there could be again 2 combinations. Like you could inherit a templatized class or you could inherit a non-templatized class. So so thinking of all of these combinations,
Yeah.
so do you think, or are there any caveats or something which we should avoid doing? Let's say use a templatized class and inherit from non-templatized or something. So is there something we should restrict, or what could be wrong, or that way?
Yeah. So the standard has not restricted any of this from happening, and C++ is all about control. You can say it is a lot to type and it is very verbose, but this is what the plus side of C++ is also. So none of these are restricted by the standard library, and you may use it to solve your own problems. So it is not restricted. For example, when unique pointer and smart and shared pointer were introduced, the regular T pointers, T stars were not deprecated or removed, because you may want to take the control somewhere. You may have some legacy code. So similarly for templates, all of this is possible, and you don't have to think about it, by the way. It's the implementer of that class, and only while implementing, let's say, a class, you want to think about creating whether this is a template of a template or not, or whether this should derive it from something or not. And usually you don't see a lot of instances where derivation and templates uh, are used much. There are clear examples like deriving from true type and false type, which the standard library definitely does. It helps you, uh, with template overload resolution, and so there is inheritance with templates, but usually you don't see. Because if you see John Calv's talk, there is a talk which he gave for 5 minutes. There's a lightning talk where he says, "Why do the cool guys not do OOP?" So I would advise you to go back and check. I had some points which resonate with that talk also. So usually you won't see a lot of overlap between inheritance and template code, but if you need, definitely all that is totally available. It depends on the use case.
Okay. So considering a situation like if I have a class template and the function is non-templatized, so that would be a user's error, right? So if he doesn't templatize the function to work on the data type, will it be a error, like
No,
the
this is
user
not
will
an
take
error.
care of?
No, this is not an error. So if you see the send function of our sender, it is
Okay.
it is not, the send function is not templatized. We were absolutely happy. We were absolutely happy on that slide, right? So send was taking two strings, remote and message, and it was in a template class, but the function was not templated.
So the function won't work then for all the data types, is it?
Okay, so if you want to support more data types than string, then you have to think about how you would abstract that. Yes. So the function will work for string or string convertible data types, but not others. Yeah.
Yeah. Thank you.
Okay. So and by the way, so even when you have the string API, the function taking string, if you passed a const-char pointer to it, it would instantiate a temporary string for the duration of the call. Okay. And that's a wastage, which is why you want to do the template. It's not that the code will not work. If you send to it, if you call that function with a pointer, const-char pointer, or a string view, it will create additional strings, and that's a wastage for a performance language like C++. So we worry about it, and so we templatize with that simple change. It works with exactly the data type that is passed.
Yeah. Thank you.
Okay. And your feedback, please, guys.
Any other questions?
Just again a quick question. So so this design patterns. So I'm not aware of that, or I'm not sure if there was a talk as well. So I did not attend. So like, are there some design patterns we need to think of for templates as well? Like, how does it go in design patterns, or some standard ways
Design patterns,
people are?
yeah, design patterns were solutions created in early 90s, and they heavily use inheritance to solve all the problems. Okay, mostly, yeah. Okay, there can be templated versions of those for sure. So templates and inheritance are just a mechanism of solving known problems. Although for me personally, design patterns are good, but do you see a lot of people applying them around you? I don't think so.
No, I don't know as well. Yeah.
Yeah. So I know from talking to people around me with professional code, even in other languages like C Sharp, etc. So they are good to know. Of course, they are set solutions for set problems. But for me, a good design which takes care of separation of concerns, there are some design principles, 5 design principles. The solid, which was also a session which Dheeraj
Hari
took,
Shankar.
right?
No,
Yeah.
Hari Shankar. Hari
Okay,
Shankar took
okay.
that session.
Okay. So
Okay.
solid principles was a session which Hari Shankar took at CPP India. You might want to look it up or look up other resources and pick up on that. That, for in my understanding, is are more important than the design patterns.
And about design patterns, Samiran, you give that in feedback form. If possible, we will cover those topics
Yeah,
also in one of our future sessions.
makes sense.
Yeah. Thank you.
So, is there any further question related to templates for Ankur? You can ask any question. Ankur is ready.
Oh no.
Okay. So I think there is no further questions related to this topic for now. So thank you everyone for joining this session. And if you have any question, you can ask on our Discord channel. Ankur is there and he is very active there. So you can ask any questions to Ankur there. And that's